Hey guys, so today we're going to review factoring GCF, factor by grouping those product and sum pairs, and then apply it to factoring trinomials, where you're basically taking these three terms and turning them into four terms so you can do the factor by grouping to factor these trinomials, okay? And you're going to be using the x to find the two new middle terms that you're going to replace with the old middle term. Sorry, my asthma is really bothering me today. So, first of all, as a review, factoring a GCF means dividing out the greatest common factor, or common factors, from each term. And if you remember, the GCF goes in front of the final answer. Because basically, to check your final answer, you can redistribute. So first thing, you want to do it in layers. You're building your GCF first by looking at the coefficients, then looking at the variables, and whatever variables they have in common, you're taking out the least amount, because like this term has 3, this only has 1. I can't take more than 1 out without getting a denominator, and we do not want denominators when we are factoring. So in this case, the GCF between 6 and 18 is 6. But I can only take 1 m out. So the 6m is the GCF. That goes out in front of your final answer. Then I just reduce both of these using our division rules. So then we end up getting 1, but we don't write the 1, m squared, because we use the dividing exponent rules. With the same base, you subtract exponents. So we move on to the second term. It's still negative. 18 divided by 6 is 3, and the m's completely divide out, so we don't have it. This is our final answer. You can do a mental math check by distributing using your exponent rules. 6m times m squared is your 6m cubed, and 6m times minus 3 is negative 18m. So number 2, we find that between 24 and 16, 8 is the greatest common factor for the coefficients. And they both have y's, but the most I can take out is 2. So we factor out y squared. So the 8y squared is the GCF. Now we just reduce both terms. And we get 3y cubed minus 2. And again, we can do the mental math redistributing to check. So 8y squared times 3y cubed is 24y to the 5th, and 8y squared times minus 2 is minus 16y squared. I'm going to give you a minute to do these last three, and then check the answer. Alright, so check these three answers, and one more tip. In order to verify that you have the GCF and not just any common factor, we always have to make sure it's the greatest common factor. The terms that are left inside the parentheses are prime with respect to each other. In other words, like for example, the coefficients 2, 3, and negative 4 only have 1 in common. And notice not all three terms have an a left. So that's one way you can verify that you have the greatest common factor, which in number 3 is 5a squared. The other thing you have to remember is if there's 3 terms in the original problem, there must be 3 terms left inside the parentheses So anytime you're dividing something by itself, like here we have the x squared. So if I show the work, you're dividing by the x squared. You have to remember anything divided by itself is 1. So that's where you get your 3 terms. And another way to verify, you distribute x squared times 4x is the original 4x cubed. 4x times 8y is, sorry, did I say 4x? X squared times 8y is 8x squared y. X squared times 1 is your x squared. And then the same thing for number 5. Now, we're using this process twice when you have 4 terms. Now, if you remember factor by grouping, the whole point of grouping is you're grouping them into pairs using parentheses. Now, the only thing is, as soon as you see a minus, you have to tuck that negative inside the group. And I just put a plus up above just to remind you that these 2 parentheses, though they look like they're right next to each other, they're not. We're tucking that negative in with the second group. Because like in number 2, I don't have to do that because I've got the plus in between the group. Now, so the first thing is pair the terms with parentheses. Okay, so each pair you put into parentheses. Then the second thing is you find the GCF of each pair separately. So the point is, the GCF for the first pair is not going to be the same as the GCF in the second pair, and that's okay. That's why I say the word separately. So in number 1, the GCF of this pair is x squared. And so when you take out an x squared, you get x squared times 2x plus 5. Now remember when we had to tuck in that negative with the second pair because there wasn't a plus in the middle like there is in number 2? That just tells you your GCF is going to be a negative. And one of the reasons why that is important is see how the parentheses in the first pair, after you took out the GCF, they were both positive. We want this parentheses to match. We want it to also be both positive. And in fact, we want it to match to be 2x plus 5. Otherwise, it's not factorable. So here, between -6 and -15, we're taking out a -3. And they both have 1y, so we're going to take out 1y. So that GCF, -3y, goes in front of the second set of parentheses, and then we just reduce each term using the division. So the -6 divided by -3 is +2. The y's divide out, so you just have the x. And here the y's divide out, and -15 divided by -3 is +5. Now, this is good because remember how I said the stuff inside the parentheses after you find the GCF of each pair? We want these to match. Then we just take the GCFs that we found, and those become one pair themselves, or the first factor. The second factor is what they had in common that had to match. So the final answer is x squared minus 3y times 2x plus 5y. And then how do we check this answer? Oh wait, so step 3, just factor fully. That's where we took the 2 GCFs, make the first factor, or parentheses, and then 2x plus 5 make the second factor, or parentheses. And then step 4, you can always do double distribution to check your answer. Okay. I'm just going to do mental double distribution. So if we have x squared times 2x, that's where we get our 2x cubed. Then x squared times 5 is our plus 5x squared. Now we distribute the negative 3y times 2y is your negative 6xy, and negative 3 times 5 is negative 15y. Now, I want to do number 2 with you. Here we divide 3x squared out of the first terms, or first pair. And then the second pair, notice we have an x minus 7. You probably think, well, they're prime. X and negative 7 have nothing in common. And you're right, where if it's just greatest common factor, we would say that it's prime. But because we're factored by grouping, we need to take out that 1, because we need that GCF out in front. So our next layer, we have 3x squared from the first pair. And when we reduce that, it becomes x minus, and then the x squareds divide out, so negative 21 divided by 3 is 7. The GCF of the second pair is 1, and since it's positive 1, we do plus 1. And then the x minus 7 doesn't change because you divide by 1, which stays the same. Now we take, okay, so good thing, these match. Then we just take the GCFs. So we have 3x squared plus 1 times x minus 7 is our final answer. And you just do your double distribution to check. So 3x squared times x is 3x cubed. 3x squared times minus 7 minus 21x squared. 1 times x is x, and 1 times minus 7 is minus 7. So it works out. Now the reason why these 2 lessons are important before this lesson. Okay, so I have to back up because I didn't realize it was off camera. Okay, so I just did this example for our product and our sum. And this was one of the last things that we did in class, where we wanted to find 2 numbers that multiply to the top but add to the bottom. So like, for example, negative 8 times positive 3 is negative 24, but negative 8 plus 3 is negative 5. So like on number 2, we have a positive product and a positive sum, so it's 2 positive numbers. Since a positive times a positive is positive, and you add 2 positives to equal positive. So 6 times 6 is 36, but it won't work for this because 6 plus 6 is not 15. But if you do 12 times 3, 12 times 3 is 36, and 12 plus 3 is 15. So there's usually more than one possibility for the top number, but you got to check to make sure you have the right combination of factors that add to the bottom number. Like, for example, on number 3, first I look at the sign. So negative 6, we know we have a negative times a positive, and since we have a positive sum, we need more positives. Well, they also have to be 5 apart, because when you're adding signs that are different, you're going to end up subtracting. Where here, they're the same sign, so they just add to 15. Well, 6 and 1 multiply to 6, and they're 5 apart. But we need more positives, so the 6 is positive and the 1 is negative. Okay. Now, let's look at number 15. Negative 30 is the product, and negative 13 is the sum. Well, we know for a product, we start with the negative times a positive. Now, a lot of you might jump to think, oh, 3 times 10, and that equals 13. The problem is, when you have 1 negative and 1 positive, when you add them, you actually subtract. So that doesn't work. We need 2 numbers that are 13 apart. Well, 15 times 2 is 30, and we need more negatives because the sum is negative. So we're going to have negative 15 times positive 2. Now, that's just as a, you can pause and do some more practice with this if this is still difficult for you, and that's okay. But this is the sheet we did, I think it was the week before, the couple weeks before, on practicing our sums with our positives and negatives, our products and sums. Now, why do we need this? Well, we're going to combine factor by grouping with the x. Now, we have 3 terms for all of these, and you're thinking, well, how do I group them? You're right, with 3, we can't group them into 2 pairs. But with the x, you're actually, the 2 new numbers that you find, you're going to basically take out the old middle term, and the 2 numbers that you find on that x, I'm not going to show you that, are going to replace this old. So there's going to be 2 new ones that go into the middle. The first and the last term stay the same. I know that may not make much sense right now. And in fact, I want to do example 3 first. So first thing you have to understand, a is always in front of the x squared. So in this case, a is 6. B is in front of the x, or the linear term. So b is -5. And then the c is the constant term, which has no variable. So that's -4. And you have to take the sign in front. So every time you set up your x, you do a times c on the top, and then b on the bottom. Okay. So in this case, when you set up your x, your a times your c is -24, and the sum is -5. So we need, actually we did that. Well, off camera. But -8 times 3 adds to -24, and they add to -5. So these are our 2 new middle terms. And you're probably thinking, well, okay, so if the old middle term is -5y, both of these need to be y terms. And we're going to eliminate that one, and we're going to replace it with these 2. So in other words, the first term always stays the same. So 6y squared stays the same. We're going to replace -5y with these 2 guys. So -8y, and since this was positive 3y, we do plus 3y. And then the -4, or the c term, just like the a term, always stays the same. We just copy them. The a term is in front, the c term is in the back. Now, we group them because we have 4 terms. And we do our factor by grouping. Well, the first pair, the GCF is 2y, and the second pair, the GCF is 1. So we get 2y times 3y minus 4, and you always put the GCF in front. So the second pair had a GCF of +1, and then 3y minus 4 is left when you divide, by 1. Now the 2 GCFs, the 2y and the +1, form one factor, and then the one that was in common, the 3y minus 4, is the second factor. Now step 4, and we'll fill this in later, you can do double distribution to check. Okay. By the way, when you have one negative and one positive, just like I mentioned in class, always put your negative first and the positive second. Okay. Now if they're the same signs, it won't matter which order you put it in. Okay, and I'll show you an example. But let's practice our double distribution again. So if I distribute the 2y to 3y, I get 6y squared. 2y times -4 is -8y. 1 times 3y is +3y, and I put them in like term columns. 1 times -4 is -4, and then we just add straight down. 6y squared minus 5y minus 4, and that's exactly the original polynomial. So we know this is the correct answer. Okay, so let's look at example 1. So I set up, this is my A, my B, and my C. The A is 2, and the C is 3, so 2 times 3 is 6, and the B is +5. Well, what multiplies to 6 and adds to 5? 2 times 3. And if you remember, the middle term is what we want to eliminate, and since it's a 5x, we just put an x on both the 2 and the 3 that we found as our product and sum pair. Here we used y instead of x because that was the variable in the problem. So you just, whatever variable in the problem, like example 2, you use an m, example 4 is c. And that won't matter, okay? So I just replace the middle term. So I keep 2x squared the same. I have positive 2x, positive 3x, and positive 3. I go straight into factor by grouping now that there's 4 terms. The GCF of the first pair is 2x, and the GCF of the second pair is 3. So 2x times, well, the 2's divide out, x squared divided by x is x, and then anything divided by itself is 1. And the GCF of the second pair is 3, so I get x plus 1, and then that finally factors in. We again put the GCFs in front, 2x plus 3, and then the common factor, x plus 1, is our final answer. Now, you might be thinking, some of you probably might have done 3 times 2. Well, I'm going to show you that if they're the same signs, the final answer you'll get the same right answer. It doesn't matter, it just will be in a different order. I'll show you what I mean. So let's say, I'm just going to cover that up a little bit. Let's say we already know the product 2 times 3 and the sum is 5, but let's say I did the 3 first and the 2 second. And then you put your x's. We rewrite the original trinomial, 2x squared plus 5x plus 3, but instead of the 5x in the middle, I use these 2 new middle terms. So let's say, so then it's 2x squared plus 3x plus 2x plus 3, and then we go straight into factor by grouping. Don't add these because that we needed to separate these in a specific way so that we could do the factor by grouping correctly. In this order, the GCF of the first pair is x, and the GCF of the second pair is 1. So you get x times 2x plus 3, and then the GCF of the second pair is 1 times 2x plus 3. So you keep the x plus 1 as the 2 GCFs is one factor, and then the 2x plus 3 is the second, because that's what they had in common. Now look, these 2 answers are equivalent. Even though they're in opposite orders, they have the same factors with the same signs. Now let's say these didn't match. It's kind of like saying 4 times 5 is the same thing as 5 times 4. It doesn't matter which one comes first. Okay. Now, to check, we do our double distribution. So x times 2x is 2x squared. X times 3 is 3x. Then 1 times 2x is 2x. And 1 times 3 is 3. And then you get 2x squared plus 5x plus 3, which was the original problem. But just know that the factored form, x plus 1 times 2x plus 3, or the 2x plus 3 times x plus 1 is the final answer. Okay. Now, let's do example 2 and 3 together, and then I want you to try the other ones on your own. So, we have our A, our B, and our C. So, A is 5, C is 6, 5 times 6 is 30, and our B is negative 17. Now, the only way to get a positive product, but then adding those 2 numbers to get a negative, is if they're both negative. Now, 2 times 15 is 30, and so if they're both negative, negative 2 and negative 15 is negative 17. Now, we're going to replace this old middle term with these 2. And I kind of left myself no room, so you put an m to replace that negative 17m with the negative 2m and the negative 15m. So we're going to rewrite this trinomial with 4 terms. The first, the middle 2, and then the last. So we have 5m squared minus 2m minus 15m plus 6. Now I'm just going to let you know, just like I did this one in 2 ways, it doesn't matter if they're the same sign, whether you have the -2 or the -15 first, but I'm just not going to do both ways, okay? If you went ahead and did this on your own and you put the -15 first, your final answer will just be the opposite order of what I have in the end. And that's okay. As long as each factor is the same sign and numbers, you're good. So let's go straight into the factor by grouping. And because there was a negative in the middle, we're just going to automatically know that the GCF in the second pair is a negative. So in this case, it's going to be -3. The GCF of the first pair is m. So we have m times 5m minus 2 minus 3 times 5m minus 2. So then our final answer is m minus 3 times 5m minus 2. Okay. And again, like I said, if you put the -15m first, you're just going to get this one first and this one second. It doesn't matter as long as you have the m minus 3 is together and the 5m minus 2 is together. Now, example 4. So again, we have our A, B, and our C. I'm not even going to label them this time, but if you need that, go ahead and do it. I just think the A times the C, so 12 times -5 is -60, and then they add to 11. So I know to get -60, I need a negative times a positive. If they're opposite signs, always put the negative first, okay? But this time, since they add to positive 11, I know I need more positives. Well, 15 times 4 is 60. But if I have the 15 is positive and the 4 is negative, they will add to the positive 11. So that works. So we're going to replace this old 11c with these two new middle terms. And we rewrite the trinomial as 4 terms using 12c squared minus 4c plus 15c minus 5. So we go ahead, we group them. The GCF in the first pair is 4c, and the GCF in the second pair is 5. Sorry, my dog is scratching. She's got a cone on. So you have 4c times the quantity, 3c minus 1, plus, and then 5 is the GCF of the second pair, times 3c minus 1. So it fully factors into 4c plus 5 times 3c minus 1. Now, just a little comment. Technically, it doesn't matter. You could put the positive 15c first and the negative 4c second, but let me tell you, it's a lot easier to not have to remember to pull out a negative if you can avoid that. If you put the negative first, when you have one negative and one positive, you'll never have to take out a negative GCF in the second pair. So pause this video and then try these on your own through number 9. I will then talk about the multi-step where you have to look for a GCF first and then do the X. Okay, so when we say multi-step factoring, that means you're combining a couple processes. Here we look for a GCF first. And when we say look for a GCF, we want to say with all the terms. Then step 2, we factor the trinomial using the X method. That's where we find the A, B, and C and the 2 new middle terms and then factor by grouping. But the A, B, and C are not the original because there's a GCF for all 3 terms, and that's step 1. Up here, these didn't because 4, 4, and 1, the GCF is 1, and they all don't have an A. So another way you can think of it for multi-step, step 1, look for an overall GCF, which is not the same as the GCF for each pair when you do the factor by grouping. Okay, those are different. So like in number 10, when we have an overall GCF, starting with the coefficients, 20, -52, and 24 is actually 4 for the coefficients. And notice they don't all have an n, so we're just going to do the GCF as 4. So when I divide out the 4, I get 5n squared minus 13n minus 6. Now, this GCF, when we have an overall GCF, is going to go in front of the 2 parentheses that we're going to get for the second half using the x method. So just know the overall GCF always goes out in front. So we're going to kind of hold this till the end. And you only want to do the x with the trinomial after you take out the overall GCF. So here our a, b, and our c are the reduced coefficients. So we're just going to do 5 times -6, which is -30 to set up our x for the product. And then our b is -13, which is our sum. Well, we need a negative times a positive. And this we talked about over here is this x exactly, where the product is -30 and the sum is -13. So we want -15 and +2. Now, we know we're going to replace this with these two, so we're no longer going to use that. So these have to become n's. I just kind of squoze that in. Didn't give myself enough room. So this trinomial becomes 5n squared minus 15n plus 2n minus 6. And we go straight into factor by grouping. The GCF of the first pair is 5n. The GCF of the second pair is 2. So you get 5n times n minus 3 plus 2 times n minus 3. And then that factors into 5n plus 2 as one factor, and n minus 3 is the second, but we have to remember this overall GCF has to go out in front. So the final answer includes the overall GCF in front. Okay. Now, let's look at, I guess it doesn't really matter, but let's do number 13. So first, the overall GCF between 15, 18, and -24, since the last term does not have a y, is 3. So this becomes 5y squared minus 6y minus 8. We go straight into the x method using our a times c, which is -40, and our b is -6. Now, because the product is negative, we need a negative times a positive, and we're going to have more negatives because they add to -6. So we're going to have -10 and +4. Since -10 times 4 is -40, but -10 plus 4 is -6. And again, we're going to replace this one. So these are our y terms. And we start with our 5y squared minus 10y plus 4y minus 8. So we group them. The GCF of the first pair is 5y. The GCF of the second pair is 4. So you get 5y times y minus 2 plus 4 times y minus 2. And that factors into 5y plus 4 times y minus 2. But again, remember this overall GCF? We have to have that out in front for our final step. And we could do double distribution and then distribute in the 3, and then that's where you would get your original trinomial. And since we had to do 2 separate total processes, that's why you would do the double distribution first and then distribute back into the 3, because you're working backwards. So do 11, 12, 14, and 15. Pause this video and try these on your own.